All right, in the last lesson, we looked at selections and combinations. And remember that what we spoke about really was that this concept that order does not matter. And it's that reason why you can't call this a combination lock, because with combinations, order doesn't matter. That is, you could put in, like if this was the combination 813, if it was a combination lock, we could also put in 318 and it should open because order doesn't matter. So what it should actually be called is a permutation lock because the order matters. Now, remember, we use this syntax to show that we're doing selections or combinations. That's NCR. So the best way to think about NCR is to think about that C as the word choose. I don't know whether the C has got anything to do with the word choose, but that's the way I think about it. So that's N choose R, right? So in this situation here, we did 3 people from 5, and the number of ways we can select 3 people from 5. That's 5 from 5, choose 3. This one was from 100, choose 98, or choose 98 from 100. Right, so let's try it out with some actual applications. Each week, Mr. Miller needs to decide who will be playing in the senior basketball team. From the squad of 11 girls, he needs to select a team of 7, 5 on-court players and 2 subs. Okay, so how many different teams could be selected? So what I've got to do is look at my 11 players and choose a team of 7. How many different ways can that happen? Well, let's have a look at what that would be. 11 choose 7 can be syntactically written like that as well. So get used to seeing it like that because that's a possible way of writing it. And that's going to be 11 factorial over 7 factorial, and then 11 takes 7, 4 factorial. Now, how did I know that? You use the formula. Okay, so back here is the formula. So n factorial, n take r factorial over r factorial. All right, so how do I evaluate that? Well, I could use the calculator, but I need to be able to be comfortable enough doing this without it. So I'm going to go 11 times 10 times 9 times 8 times 7 factorial over 7 factorial times 4 times 3 times 2, not times 1 because that really doesn't matter. Right, let's cancel the 7 factorials out. Now, let's see what else we can slash. Right, so I'm going to slash that. So 4 times 2 is equal to 8, so the 8 can slash. That can slash with the 9. And we've got 11 times 10, which is 110. 110 times 3 is 330. You can also do this on the calculator. So if we go to the calc, you can see I've done some there. And go to the advanced section again. We can use this command here, or this function, NCR. What we do is we type in 11, then a comma, and then 7, and that represents 11 choose 7, which is 330. Right, if Kate is the star player and must be in the team, how many combinations are possible? Okay, so now what that means is I need to choose a team of 6 from 10 players because Kate is removed out of the potential players. She's just automatically going to be on the team. So there's Kate and 6 others. Okay, so I've got 10 possible players to fill those 6 spots. So I'm going to do 10 choose 6. What is that? Well, that can be written as that, which is 10 factorial over 6 factorial, 4 factorial, which is the same as 10 times 9 times 8 times 7 times 6 factorial over 6 factorial times 4 times 3 times 2. Gone. 4 times 2 is 8. That's gone. 1 and 3. So this is 10 times 3, which is 30. 7 times 30 is 210. Just check that out. 210. All right, so if Alex, Jess, and Emily are going on a music camp, and will be unavailable to play. How many combinations are possible, assuming the talented Kate must be selected? I don't think that's actually in your notes, so just add that little sentence there. All right, so let's just check it out. So we've got Alex, Jess, and Emily are going on camp. Previously, we did 10 choose 6, but we don't have 10 anymore. Now we've got 7 players to choose from because 3 are on music camp. And how many spots do I need to fill? Assuming Kate is going to be selected, that's going to be 7 choose 6. Now, if you recall from your rules, 7 choose 6 is going to be 7. Okay. Now, that is which one? That's this one here. So 4 choose 3 or 6 choose 5. If this number here is 1 less than this, it's going to be 7. But if you forget that, that's fine. Let's just use the rule. 7 factorial over 6 factorial, 1 factorial. 7 times 6 factorial over 6 factorial, and 1 factorial is just 1. That cancels out, so it's 7. All right, so 10 people have volunteered to help with the annual Corunum. There are 4 Year 12s and 6 Year 11s. Ms. Tran needs 5 people to help with the layout. Now, sometimes I feel like it helps just visualizing things here. So here are my Year 12s, and here are the fabulous Year 11s. Not that the Year 12s aren't fabulous, but what's that? That is 6. All right, so there's the 11s and there's the 12s, and they're all vying for positions on Corunum, or these 5 positions. Now, how many different groups of 5 are possible? There's no restrictions at the moment, so this is from 10 people, I need to choose 5, so that's 10C5. That's going to be 10 times 9 times, jumping the gun a little bit there. Let's go 10 factorial over 5 factorial, 5 factorial. 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 5 times 3, 5 times 4 times 3 times 2. See you later. Those two are gone with the 10. 4 goes with the 8, leaving 2. 3 goes with the 9, 3. So we've got 3 times 2, which is 6. 7 6s are 42. 42 times 6. So I think it's 252 if my maths has worked out. 10 choose 5. 252. Yeah, okay. All right, how many different groups of 5 are possible if all 4 Year 12s must be allowed to help? All right, so the Year 12s have kind of pulled rank and gone, it's our final year, guys. Like, we're going to be helping on the magazine, Year 11s, so stand back. All right, so what would have to happen? We still need 5 people. So from the Year 12s, what I'm going to do is from 4, I'm going to choose 4, okay? And I've got to choose a Year 11. Okay, so from these 6 Year 11s, I'm going to choose 1 lucky Year 7. Okay, so from 4, choose 4, multiplied by from 6, choose 1. Okay, now what's this going to be? Well, 4 choose 4 is just 1. How many different ways are there of choosing 4 people from 4? There's just one way of doing that. Now, how many ways are there of choosing 1 from 6? Well, that's going to be 6. So there's 6 different groups are possible if this is the case. All right, how many different groups of 5 are possible if there must be a majority of Year 12s? All right, so again, I find it easier to kind of imagine this with people. So we've got groups of 5, okay, and one of them would be a 12, a 12, a 12, an 11, 11. That's majority Year 12s. We could get 12, a 12, a 12, a 12, and an 11 as well. So that's 4 Year 12s. We can't get 5 Year 12s because there's only 4 of them. And if we get 2 Year 12s, that means there must be 3 Year 11s and the Year 12s don't have a majority. So these are the two conditions we're after. So what we're going to look at here is from the 4 Year 12s, I'm going to choose 3 multiplied by from the Year 11s, which there was 6, I'm going to choose 2. Or, so our other option is or, so we're going to add these results together. From the Year 12s, 4 choose 4, multiplied by from the Year 11s, 6 choose 1. All right, so this one here we already know, that's going to be 6. Now 4 choose 3, this is 1 less than this, that means that one is 4. 6 choose 2, well 6 choose 2 I might just have to do using the formula, so that's 6 factorial, 4 factorial, 2 factorial, which is equal to 6 times 5 times 4 factorial, 4 factorial times 2, that cancels 3, 3 5s 15, 4 times 15. All right, so that's 40, 60, and that's 6, that equals 66. All right, how many groups would have at least 1 Year 12? All right, so I could have 12, and 11, 11, 11. Let's just break these up a bit so we can see it a bit better. And 11, and 11, and 11. That's at least 1 Year 12. I could have a 12, 12, and 11, whoopsie, 11, and 11. I could have a 12, a 12, a 12, an 11, and 11. And I could have a 12, and a 12, and a 12, and a 12, and 11. So I've got that, 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 and that. Now I've worked out some of these previously, okay? So I could tack on these other ones here. But wait a minute. How many groups would have at least 1 Year 12? That means not, what does it mean? How many groups would have at least 1 Year 12 means at least 1 Year 12s, not all Year 11s. Okay, so why don't I work out the chance of getting all Year 11s, okay, so no Year 12s, and then remove that from all the possible combinations that are allowable that I worked out in part A. So I'm going to say that this is going to be 252 subtract, all right, 4 from the 4, I'm going to choose no Year 12s, bad luck Year 12s. All right, multiplied by from the Year 11s, from the 6 eager Year 11s, I'm going to choose 5. Okay. Now 4 choose 0. What are the chances of getting nothing from 4? That's just 1. 6 choose 5 is 6. So this would be 252 take away 6, which is equal to 246. Okay, if you wanted to check it out, you could do it the other way. I have a confession to make, and I will confess this in this video, is that 1 year I did do the problem like this. I just wasn't thinking deeply about the problems, and I wrote up this, I wrote up this, I wrote up this, and I wrote up this. And this whole thing was just full of calculations. I had to work them all out. And I got to the end, and there was a couple of girls just sort of mumbling a little bit or pointing at something, and a kid says, couldn't you just remove the chance of getting all Year 11s from 252? And I sort of had to think about it, and I'm like, ooh, that would have been nice to know about 10 minutes ago. So good to see that student was thinking about this deeply. Yeah, what a waste of time doing all of that was. So make sure you think about this, and invariably, if you've got that many calculations to do in a problem, there's usually an easier way, and it's usually this thing. So I can't believe I did that year, but them's the breaks. All right, let's go through this last problem, or second last, I think it is. In each entry for Saturday Tats Lotto draw, you must select 6 numbers from the 45 available. To win First Division, all of your numbers have to come up. All right. So how many single entry combinations are possible from your 6 numbers? So from the 45, I'm going to choose 6 numbers. And this one here has got to be done on the calculator, okay, because Playing Tats Lotto is ridiculous. Don't bother, because that's the number of single entry combinations. 8145060. You got to be in it to win it, but bugger that. What are your chances of winning with one particular entry? Your chances are your one entry over 8145060. That's your chance of winning Tats Lotto with a single entry. All right, you could take a System 7. So Tats and whoever else is making these tickets comes up with these fancy names for things to make you think like, oh yeah, like this is going to give me a really good chance of winning Tats Lotto. Okay, but here's a little bit of a encouragement for you. Money does not equal happiness, or wealth does not equal happiness. Okay, so everyone thinks that winning Tats will make life absolutely amazing for you, but I believe that you've got to derive something else in life other than just getting some money. Anyway, back to the mathematics. You should take a System 7, which allows you to select 7 numbers, and the computer works out all the different combinations of 6 numbers that are possible from these 7. How many single entry combinations does a System 7 give you? So from 7 numbers, we choose 6. Right, 7 choose 6 is just 7. Okay, so how many different ways are there of choosing 6 numbers from 7 numbers? There's 7 ways to do it. All right, what are your, look, if you get this System 7, your chances are going to be fantastic, aren't they? Well, not really. That's going to be 7 choose 6 running the System 7 over 45 choose 6, the total number of possible entries into Tats Lotto. So that's going to be 7 over what we know is a very large number, 845,000,060. Make sure that vinculum covers all of those numbers. All right, so there's my probability. All right, and this is a formula that comes up in a book, and it'll allow you to answer some of the problems. So I'll just quickly explain how it works and give you an example of where it'll be used. So selections of any size. The following formula is useful when asked to count all the combinations of any size from a group of n objects. So I'll just try to demonstrate why this formula can be done by just simply going 2 to the power of n. So you can see using this example here. So there are 3 different books, A, B, and C, and Daniel can choose however many he likes, including choosing none of them. So how many different ways can this choice be made? Well, I've drawn them out here. He can do no books. I am not taking any books, says Daniel. He can choose book A, book B, book C, A and B, A and C, B and C, or they're all fantastic, so I'll grab all of them. Therefore, the options of number of books he could choose are, so 0 books in one way, that's from 3, choose none. Okay, that's 1. 1 book in 3 ways, 3 choose 1, 2 books in 3 ways, 3 choose 2, 3 choose 3, which is equal to 1. Okay, so using the addition rule, we note that that's going to be 8. But actually, let's think about it like when he chooses the books, like it's not like he grabs all 3. The same thing could be done by choosing the books one at a time. All right, so book A, yes or no. Book B, yes or no. And book C, yes or no. And if you know what's going to happen here, I'm running out of room. What we've got is 8 options. Okay, so either it can or it can't be done. Okay, so by the multiplication rule, there are a total of 2 times 2 times 2, or 2 to the 3 choices. So we can extend it to the rule above. Okay, and just one thing to note, that if 0 is not a possibility, remember to subtract 1 from the options. Okay, right, so how many colors can be obtained by mixing a set volume of red, blue, green, orange, and white paints if any number of paints can be used at a time? All right, so what does that mean? Well, I can either use red or I not use red, blue or not blue, green or not green, orange or not orange, white or not white. So that's this situation here. We've got 1, 2, 3, 4, 5. This is going to be 2 to the 5, and that equals 32. So 32 different colors. But. Okay. What we also need to do is remove 1. Now, why do I have to do 32 take 1? Well, what will happen is within these 32 choices, the choice of no red, no blue, no green, no orange, and no white is included. Okay, and look, if I'm thinking of doing some painting and my wife sends me off to Bunnings to get some paint, if I come home with no paint, she's going to look at me and be like, Paul, you've got no paint. Okay, so I need to remove that situation here. That's not a possibility. If she sends me to get paint, I'm coming home with some sort of a mixture of paint. So I've got to do 32 take away 1, which is 31. There's 31 possibilities there. All right, so check the study or the set questions there and do those questions from 10C, 10D as well. There's some pretty hard questions in 10D. When you find that difficult, I say when you find that difficult, know that it's tough stuff.